the Alex Manassa, and I believe we just left off at designing a schematic for a taser. So here it is. We got our 555 timer-based primary stage. Its job is to switch off and on an inductor, which is not shown here. I've just put a connector to be in place of the inductor because there wasn't really a good footprint for an inductor. You got to be sometimes a little bit practical when you make your schematic. We've got our secondary stage, which is a voltage. I don't think this is called a voltage ladder, but just a diode capacitor crisscross, so that as the AC voltage oscillates back and forth, you're going to start working AC voltage up here and charging this diode capacitor ladder until you can discharge test point 1 to test point 6, or really test point 1 to any of these test points here to get a different voltage. All right, so we want to make a circuit board with this now. Let's give it a shot. First, we got to create our netlist. So we've made our schematic. We have assigned everything a footprint. We should be good to go. If I forgot anything, it will be in an error list. All right. Excuse me there. All right. Here we go. Here we go. Here we go. Let's pull it in. We're going to update PCB from schematic. It's going to give us a nice little window here, hopefully. Maybe. There we go. All right. I was wondering if we were having another issue there. Okay. Looks like we've added everything. Everything looks good. 0 errors, 0 warnings. Update the PCB. There it is. There's everything. All right. And now we have all of our components just flippity floating here. Grab that. Let's zoom on in. Okay. So first things first. We're going to make this circuit board look like our schematic in terms of layout. Now, when you're working with a schematic, you make it logical. Like this 555 timer looks pretty logical. You can sort of just look at it and see how this thing works. We're going to do the same thing with the rest of this circuit. We're going to lay this thing out like the schematic. Sort of at the top. Now, if there's a voltage difference of 400 volts, oh man, what am I going to do for that? I need to have a gap. Circuit voltage gap. No, I don't want gain. Component selection, blah, blah, blah. Listen, all right, so if I'm doing an air gap, I mean, I could do some more research on this. I don't want you to sit here and watch me read things for like 4 hours. But if we were going to make this thing have an air gap, I want to see what the measurement is. So let me see. Do we have a measurement tool here? No, that's selecting the units to inches. Tools, inspect. Here we go. Measure. I want to measure from... Actually, you know, I don't want to measure that one. I want to measure from pad to pad. It's like here to here. What is that? That is 4.32 millimeters. So it's like a fifth of an inch, about a sixth of an inch, really. Yeah, I think if they're connected, I think that if the nets are connected, then it's obviously you can have, you know, they could be right next to each other because there's no voltage difference if they're shorted out. Alright. I'm going to go ahead and save this thing, because I'm going to put the button back in now. I need to put a button in here. And I might as well do it now, because you don't want to wait on that. Okay, switch. I need... Nope, not an analog switch. Alright. Not a dip switch. Here we go, switch, push switch. Alright, let's do that one. Okay. Move you over here. Kill you. Take you. Clickety clickety. Clickety clackety. Very cool. Oh. I'm just going to call you switch 1 because I know that that's the only switch we've got. Footprint. Pop it up. Pop it up. And the switch is... Huh. Somebody put in a button? Yeah, alright, there you go. Okay, let's see what we got in terms of switches. We got dip switches galore. So many dip switches, holy crap. This looks pretty good. So this is a B3S1000, huh? All right, cool. Hey man, I already got the footprint here, so I'm just gonna use it. I'm being lazy. Call me crazy. Power or on. How about that? It's just gonna exist as a. This is just gonna exist as a circuit board guy. All right, so I'm gonna go ahead and generate the net list. Create the net list. Do it. Save over it. All right. Now we're gonna go back to the circuit board. And we're gonna say update PCB. Do it. Close. It loves it. There we go. See how easy that is? Yeah, why put it off? You just get it done. Not a big deal. Now I'm only putting stuff on one side of the board. That's a big... It's kind of a wasted opportunity. So I'm just going to start flipping some stuff. Like, why not put this on the other side of the board? There you go. What else? What else can I put on the other side? Perfect. It's great. Do it. I love it. Okay. See how much tighter that's making everything? That's awesome. That is awesome. Also, these are... So this is going between 2 3-hole components. It doesn't matter which side of the board, but... Yeah, it doesn't matter which side of the board. So I'm just going to put this guy real tight in. Right here. Yeah. Okay. And you are going between 2 pins, right? So, yeah, you're getting flipped. Get flipped. Go flip yourself. Awesome. Okay. Getting tighter and tighter. Look at that. Look at that. That's beautiful. That's a beautiful circuit right there. All right, is there anything else I want to put here? Okay, I'm going to take these capacitances. I don't think these need to go up front either, you know? Yeah, all right, if I'm not putting the capacitance values on the silkscreen layer, then I'm just going to go ahead and turn off the fab layers now because I don't need them. That's going to make my life a lot easier. All right, D6, you're right there. See what we're looking at. Now that is a nice tidy board. Now see, I'm wasting some space here on the right. I can move TP6 in, move all these in. Yeah, test points are just loops. You'd stick your little grabber on. I don't have any grabbers sitting out, or I'd show you. But you have these little grabbers for your probes. You just grab onto these. So there's no 3D model for the on switch. It's a shame. That's kind of cool looking, but you can imagine it there. So that's this board. All right, so I'm going to go ahead and move these test points over to the left just a bit. You get it? All right. Okay. And what does that do? What does that get me? All right, not too bad. And there's plenty of space right here for a title block. That's perfect. I'm going to make good use of that space. Love it. Okay. Let's go ahead and put our boundary on here. Edge cuts. I always forget if it's graphic line or graphic polygon. I don't know, man. That looks pretty good. If you hold control, the line will stay straight. And that way you can just use the horizontal or vertical bar to adjust yourself. There we go. That's it. Let's put some text on here. What? Verboten. Okay, yeah, forbidden layer. The forbidden layer. Okay. I'm going to say Taser board rev dash a Manasseh. We like to keep it nice and simple here. Oh, bugger. Put it on. Where's front seal screen? There we go. I just want to edit you. That's all. Left justified and let's make the width like 2 millimeters and the height like 2 millimeters. What does that do? Oh my gosh. Okay. This is the easy part now. Once you've planned everything out, then it's just super simple. Boop, boop, boop. There isn't even that much ground. Honestly, there's no real reason to have a ground plane, you know? So let's hit the DRC check and see how it's going. This is the part where we get disappointed. Do it. Oh, wow. Oh, right here. Cool. That's it. We done. We done, son. Only thing I might change is I might want to move this over to the edge. That's it. Pretty small, things considered. I don't usually like to do right angles, so I'm just going to grab this and oh my gosh. What was that? There we go. That was the free-handed free angle guy. Okay. All right, cool. So I'm going to save this guy. Let's go ahead and generate some Gerber files. Got to go to file, got to go to plot. All right, cool. We don't need paste. Mask, silk, edge cuts, cool. Everything else is cool. Output directory is the same as our current directory. That's fine. Plot it. All right, let's generate some drill files. Exelon drill file format. Absolute origin, decimal, yep, format, cool. All right, let's do it. All right, so now we're going to go to our directory. Tekjuku, technical work, hardware, PCBs, the Taser. And in the Taser, we've got our files. I'm going to grab all of these guys. These guys. I think that's everything. And I'm going to throw them into a... Actually, let me check. All right. We got bottom copper, bottom mask, bottom silk. We got the edge. We've got the top copper, top mask, top silk. And then we got the drill jobs. All looks good. Looks great. We're going to 7-zip this thing into an archive. Add to taser.zip. All right. Now we're going to go over here to OSH Park. All right. So OSH Park. Once you have made an account here, let me see. You can upload these Gerber files. And it is pretty cool. So I'm already logged in and everything. And look, there's the board right there. You can just check this on your own. It looks right. Everything is where it should be. I see silk screen. I see drills. I see copper. I see solder mask. All looks good. Everything looks pretty good at the first glance. Yeah, I like it. All right, so Taser, Rev Dash. Okay. 3 boards going to be $15. Top board, bottom board, drills. Solder mask, there's the board outline. It does a full breakdown for you and everything, so you can see everything. It's great. I'm going to end it there. From there, all you got to do is put in your credit card information, and then you've got it. Oh, wait a second. All right. Cool. I'm going to go troubleshoot that. I'm still in the corner, though. It's so confusing and weird. I've got some weird gremlins going on. Okay, I will see you guys later.